It is actually extremely convenient to have a channel like this, because right now whenever I need to explain something really quickly, I can just make a video of this. It's much more convenient for me. So MKT multi-app, it's actually a project of mine, discontinued a while back, mostly because of the three, at least that's how many I think there are, different memory leaks that happen in the code, which are borderline impossible to fix. Manage your memory, kids. So memory management is important. So here's the thing. What is MKT multi-app all about? Well, first of all, it's Vulkan. Vulkan helps you with graphics. So it's obviously a graphical engine. So here's the basic idea of how graphical engines work. You have a graphical engine, you input into the graphical engine some information, and then graphical engine outputs on your lovely computer monitor screen. It outputs just images, which is really nice. Now, here you may obviously ask the question, make it, why would we ever need a graphical engine? What is the point of that? Can't you just take this data and put it right to the screen? For example, if you, for example, want to display a square, right, that's 10 by 10 pixels, a red square, 10 by 10 pixels, can't we just input it straight into the monitor screen? And the answer is yes, you can. With a CPU, you can, absolutely, it's easy. But the thing is, when we're talking about graphics, we don't really want to use a CPU, a central processing unit. What we want to use is a graphical processing unit for graphics, obviously. So here's what we do. What we do is we take this data from the CPU, we use the graphical engine so that the graphical engine can kind of put the data, kind of pass it and put it into the GPU, and then using this GPU we can display it on the monitor screen. That's the general reason for why graphical engines exist. That's why Vulkan exists, and Vulkan is by far the lowest level and still best graphical it's not a real library. I still haven't found a way to describe it. I've worked with Vulkan for years now and I still have no idea how to describe it exactly. But yeah, so that's what the graphical engine is. Vulkan just basically allows your code to use a GPU in a way that's more convenient. So you don't have to code everything from scratch. Vulkan allows you to access the GPU, kind of tap into the resources. Right now, I will not explain everything when it comes to MKT multi-app because it is the largest computer science project I have ever done. But here's the basic idea. The basic idea was that when it comes to the MKT multi-app, the way it would work is it would not only handle from the CPU to screen, but it would also handle DLLs, which basically means that you would have, I called them MKT, they were MKT something. Modules. I call them modules. So basically you would attach a module, and what was so amazing about DLLs is that what's so fun about DLLs is that when your program is running, you can attach this module whilst it's running, and it would have still around the same speed as if it was pre-compiled. So you would basically have the same speed. Basically you wouldn't lose any speed, while at the same time you would have all of the freedom you would ever desire. So and that was just once again, I know I'm not providing the best explanation for it, but it's just large. It's not difficult. Once again, it's not difficult, it's complex. There's many things going on. So you would attach these modules for anything you would ever want and ever need, and then the basic idea was that you would have the MKT multi-app and you would take the data from the CPU. It would take this data, it would access all of these modules, or these modules could also create the data, and then it would upload it into the monitor screen. That's the way it would work. Now, you are probably familiar with Unreal Engine, I'm guessing, or Unity or whatever. The way they work is they are pre-compiled, which basically means that you create your program in Unreal, for example. At least I know that's how Unreal works. So you create your program in Unreal, and then you hit compile, and then you have your ready game or simulation or whatever. The way it's different from how MKT multi-app would work, because when it comes to MKT multi-app, you would just start MKT multi-app, and you can basically join in these modules together during runtime, which basically means you can edit stuff as you go and it still wouldn't lose any speed. That's why it was so amazing. But as I mentioned, amazing in my opinion, it will always have a place in my heart. But today I won't be talking about the multi-app, because that would take a lot. Instead, I'll just quickly explain this build file. So, what's the deal with the build file? Build file, I just made it because normally without this build file, I would just have to input all of these commands one by one, and that's just a lot of work. So yeah, that's the only reason for the build file. Alright, so here's the thing. First of all, switches, that's just boring. That's to make things easier for myself. Windows is true because, well, that's for compilation on Windows, so I just, by default, I set it true. If I'm debugging, then I want to be debugging. This is just a define for my C code so that this basically turns all of my code that I made myself for debugging, just turns it on, and this turns on default debugging flags for the compiler, which means that compiler would compile a code that's slower but easier to read, and that you can actually debug later on. If I want to compile DLLs, then what I will do is then the compiler, GCC, that's the compiler for C. You have G++ for C++, and you have GCC for C. So the compiler basically takes the file and then includes, I think, oh boy, it's really been a while. I think that is include, basically change the include path to source, because that's where all my includes are. Then as the debug string, so if I'm debugging, then adds this. And then shared basically means a shared library or a dynamically loaded library, DLL. That's what just creates these DLLs, so creates these modules. These modules here are just the testing modules that I made for file conversion. Oh, this has actually been a lot of fun. This is pretty cool, but a topic for a different video. Then, if I want to compile shaders, then I would compile shaders. What shaders basically do is, C is a great programming language. I absolutely love it. But right here we want to access not the CPU, only the GPU. And the problem is that accessing GPU with C, well, I think it's the 5th circle of hell, I'm pretty certain. So instead what we do is we use Vulkan. And in Vulkan, basically you use C in order to move everything you need from the CPU to the graphical processing unit. And then in the graphical processing unit, you need to program the code for the graphical processing unit using a different language, GLSL, I'm pretty certain, I think that was the language. And then you need to take that language and then you need to compile it. These are just executing different batch files, which just have all the other different commands to, to compile these shaders. Then ifmath, the reason why ifmath is here is that I have made my own mathematical equations in assembly. There is absolutely no actual reason for it. The only reason was that I wanted to. I thought it would be funny because, assembly is well known for being both extremely difficult and extremely quick. And you know what? Obviously, in C, all of these basic mathematical stuffs, they are already optimized to their limits, but I thought, you know what, I can also try it myself. So I did, and basically I created my own math in assembly. That's the 4% assembly code. That's in the engine. That's what it is. It's basically my own math. And it is creating it into an object. What object file is, it's you have a dynamically load library and the statically load library. So we have dynamic and static. Dynamic, as the name would suggest, links dynamically, which means during runtime. So we can start the program and then you can link it dynamically. Statically, on the other hand, means that you have to link it during program compilation. So right here, I don't know why I was using Clang. Clang is also a different compiler. You have GC and you have Clang. I don't remember why. It's really distant past at this point, but yeah, this just combines all of the files together, all of the libraries together, Vulkan, everything together, and just creates a single executable from it. A single massive executable in build main exe, and once you execute that executable, then the engine starts. There we go. And I know it's not as clear because it's a pretty massive project, but here's the thing. This creates the engine. Okay, maybe I should go chronologically. This creates the math, which then goes into here and is linked to all of the other files, and then they are all compiled into a single executable. Then once you start this executable, you are linking these files. The reason why I created these files is I basically wanted loading in of all different files to be in separate libraries. So the way this works is you have a single engine. I'm actually really proud of this system. You have a single engine, and let's say you want to load a JPEG, right, into this engine. What you would do is you would take the JPEG in, and then the engine would basically check in a file right here, right? It would check in a file, which is just a list. It would check if it can handle, it would basically check in that file if it can handle that file format. And if in that file it says that it can, then what it would do, it would take back this message, it would say, yes, it can. Yeah, that is right. Yes. Yes, congratulations, you know how to read the JPEG. Then what it would do is it would go into a folder where it has these dynamically loaded libraries for each file. So in this case, if it's a JPEG, then it would load in, I had a naming convention for it, MKT JPEG. That's what it would just load. Yeah, for AG array graphics, that's my own file format. MKTP is also my own file format. Then what it would basically look for is a file which is called jpeg.dll. And this file is basically its own very program which knows how to load in JPEGs, and then it would, this graphical engine would basically take in the JPEG, it would put it into this dynamically loaded library, and the dynamically loaded library would bring back just the image data. Because as you probably know, JPEG is not just every single pixel listed as a color, it's compressed. So it will basically decompress the file, parse it, and then just bring back only the pixels. Only the pixels, and that's it. And then depending on what the program wants to do with that, so then you would have another module right here, let's say it would be a game. And so this module would tell the engine, hey, I want to load in this JPEG. Then this JPEG would tell the engine, hey, I'm a JPEG. And so this engine would ask the file, hey, can we read JPEGs? The file will say back yes. So then the engine would check in its DLL, so would check for jpeg.dll. This DLL would bring back, would basically take in this picture, and as you can see, this arrow right here would take it in, and then would bring back the picture data, and then the engine would bring back to the module itself just the picture data. Now, extremely convoluted, extremely complex, seems pointless, seems ridiculous. Why is that a thing? Well, because from the perspective of a programmer that's creating only this module, here's what you're basically doing. You have the engine, and then you have your module. And let's say you want to load in some cat.jpg, right? Here's what it would look like from your perspective. You ask the engine to load in cat.jpg, and the engine brings you back the pixel data. That's it. There's nothing else going on. That is it. It's so convenient. So yeah, from the perspective of someone who's creating an engine, it's an absolute pain. From the perspective of someone using an engine, it's actually pretty nice. And the reason why all of these are separate DLLs is, let's say that one day a new file format is created. Let's say, I don't know, MP11, right? Just the crazy, I don't know, that's not how it works, but let's say MP11, it gets created, right? Then you don't have to reinstall the entire engine. All you have to reinstall is just one file called mp11.dll. And that's why it's so convenient. The engine stays the same. All you do is you add modules to it. What's even better is that if this, let's say that you have this engine open, right? And this new file format gets created. You don't even have to close it. You don't even have to close it because there is no need. You just add another file. And during runtime, you don't have to close the engine. Can you imagine if that was a thing in real life? If I just open Discord, okay, Discord is a bad example, it's extremely high level. If you open some sort of game, right, and you can just add on new file formats whilst the game is still running, and there will be no errors, no problems. So that's why MKT multi-app was, I was so excited about it. The issue is that this is a lot of pretty advanced stuff, and somewhere in that code there is a memory leak, which is overwriting all the data, which is breaking the entire engine. But there we go. Yes, that has been my TED Talk. Hope you enjoyed. I'm so glad I have the show.